All right, guys. So let's go ahead and start. If Fletcher and Grace join us later, great. But let's go ahead and start. All right. So I was thinking the first hour we would focus on programming, and then second hour from 4 to 5 we would focus on project and design related stuff. And I'll show you guys a couple of things. So we're gonna do programming first, and I'm gonna be showing you guys two pretty important programs today. I've kind of been like experimenting a little bit with these programs, and I think they work pretty well. So I'm going to be teaching you guys these two programs today. They kind of, you can kind of get, I guess, a little caught up in like the program. It can be a little difficult to understand. So if you guys don't understand, let me know. And if you don't understand right now today, that's fine because it is a little complex. But we're going to be programming in EB3 Classroom. So if you guys can open up that would be great, and you can follow along. But yeah, that's what we're going to do first.
Wait, do we need our bricks?
If you want, you don't have to. I'm going to be showing mine. I'm actually going to be showing you got your robot. That's what I used to program this. So, and after we're done, I was going to use my phone and just record these two programs working as well. So the program we're going to be making today is both of the programs we're going to be making today are gyro programs. So, you know, in FLL, you definitely want to use the gyro sensor. So who knows what the gyro sensor does? And I think we've talked about this before.
Me. I know what a gyro sensor does.
Okay. Yeah. What does it do?
So it helps your robot make precise turns and go forward precisely.
Yep. So gyro sensor measures angle, and if you guys, I don't know what math you guys are in yet, but angle is basically like if you think of a circle, or just think in general, like how far you turn, that's called an angle. It's measured in degrees. So if you guys have seen like a fancy tool, like I think I have one here. It's called a protractor. I don't have one on my desk. And it's called a protractor, but that basically helps you measure angle. So the reason we want to measure angle, why would I think Karthik said it, we want to go straight. So in FLL, you always want to make precise turns and precise. Oh, someone.
The host.
What was that?
He left.
Okay. So in FLL, you always want to make precise turns, and you always want to be accurate with everything you do. So the gyro helps us do two things. It helps us move forward in a straight line, and it also helps us make precise turns. So if we want it to turn exactly 135 degrees to the left, then we could use the gyro sensor to make those turns instead of just telling it to go to turn left for, I don't know, 2 seconds or something like that. That wouldn't really be a good way to, no. That wouldn't really be a good way to go about making turns and moving forward. So the first program we're going to do is to have our gyro or our robot move forward. So I'm going to hop on EV3 Classroom. I hope you guys can see my screen. And this is the second program that we're going to be doing. This is the turning program. Yeah, so it looks pretty big. So I don't want you guys to get lost. What was that?
That was just to turn?
Yeah, to turn at 90 degrees. I'm telling you, these programs are, they should work like every time unless the gyro acts up. I spent some time like experimenting. So these programs they work really well. I'm gonna click on get a new project, and if you guys should probably follow along so you know how to do this yourself, or at least you know how it works.
Oh, okay.
Yep. So the first one we're gonna do is gonna be this one. So I actually made two of these. So the first program is to move in a straight line, and that's this right here. So this uses the one gyro sensor, and this helps us move in a straight line. So if the robot's moving forward, and let's say like it gets hit by the side or something, it probably wouldn't happen in FLO, but there are other ways that the gyro could get off track. But if it gets hit on the side and it's skewed, it would correct, this program corrects itself. So it only moves in that straight line. Yeah, so in FLO, your robot's probably not going to get hit by anything, but sometimes the motors, especially the motors, they might not be exactly at the same power. So you can set your motors to be different powers or the same power, but it might not always work like that. For the most part, it doesn't. If you guys have ever tried to run anything with just the movement blocks, they don't always go straight, right? So the gyro helps us go straight, and it helps us make really accurate turns and movements. So that's the first program we're gonna work on. So, or I think I already did it. So I just clicked on a new project, and you guys can rename your project by just clicking the three dots up here and then rename. So I'll keep mine as project since I already have the names of those. All right. So this program, like I said before, is gonna make our robot move straight really accurately. So the first thing we want to do is we want to reset our gyro sensor. So if you guys look at the top of my screen, I have your robot or your drivetrain or whatever. I have it connected to my computer. So you guys can see on the top there, what is it showing?
The motors.
Yeah, it's showing the motors, and it's showing the angle, or sorry, not angle, the angle that they're at right now. So I don't know if you can switch it to rotations, but yeah, it's showing the angle right now. So that shows that it's connected. And then if I connect my gyros, it should show them. Let me see if I can plug it in. So that shows us all of the stuff that's connected to our EV3. So right now it's showing the motors. And hopefully in a little while, once it connects, it'll show our gyro. But anyway, the first thing we want to do is we want to definitely recalibrate and reset our gyro. So we're going to do two things first with the gyro. And we're going to first recalibrate our gyro. Recalibrate our gyro. So I think last time we talked about like the difference between recalibrate and reset, and I wasn't quite sure, and I said I'll get back to you guys. So the difference is that when you reset a sensor, you're completely like you're resetting its system. Oh, okay, someone just entered.
And Grace.
Yep. Hey, Grace. So Grace, we just started programming. I'm on EV3 Classroom, and we're making a program to make our robot move straight with the gyro.
Okay.
All right, so yeah, so the difference is that when you reset a sensor, you are making whatever it's starting at 0, basically. So if I were to reset my gyro sensor, whatever angle it's moved at, like if it's turned 90 degrees, if my gyro is turned at a 90-degree angle, it's gonna say that's 0 once I reset it. What recalibrate does is it allows your sensor to make better measurements. So it doesn't make your current reading 0. It just makes it work a little bit better. So we want to do both to begin with, because we're pretty much predicting that whatever we're going to start at is going to be how we want our robot to move. So we want it to move in just in that straight angle. So the first thing we want to do is, or I should mention, we're going to be using a bunch of different variables in here. So we should probably actually make that first. So do you guys know what a variable is?
Yeah.
Yep. All right, so what's a variable?
Can I see it?
Can you see what?
Can I say it?
Oh, yeah.
So a variable is basically something that stores a value. So like, let's say I make a variable called multiplier, like in that program. Whatever you set it to, whenever you use multiplier, it's always gonna like refer to that number or like whatever it's set to. So like if you set multiplier to 1 and use multiplier somewhere in your program, it's gonna refer to 1.
Yep. So a variable basically holds the value of a number, and you can use it a bunch of times in your program. So that's what we're going to be making first. We're going to be using a couple, and you might not know what they are now, but once we get farther along in the program, you'll be able to see what they do. So we're going to be making, I think, 3 variables. So let's go down to the variable area, and I'm going to click on make variable. So the first one we're going to make is going to be a multiplier, and I'll tell you guys a little bit about that later, but we need to make this one first. So it's just called multiplier, and I'll click OK, and then we have that, and I'm just going to take out the set multiplier block. So this is going to set our variable to whatever we type in. So right now it's 0. We're going to change that later. So we'll just keep everything as 0 until we use it. So the next variable we want to make, I'm going to click make a variable, and that's going to be rotations. So the unfortunate thing with the EV3 classroom is that you can't really measure rotations. So you can measure degrees, but you can't measure rotations. It uses rotations like in the movement area. So like I can move something for 1 rotation, but if I want to actually see how many rotations a motor has gone, it doesn't give me that. It only gives degrees, and it only gives speed. You guys can see that. So there are no rotation blocks. So, and I mean, that's an easy fix because 360 degrees, which would be 1 full turn for the motor, would be equal to 1 rotation. So we can just do a little bit of math there and convert our rotations to degrees, since the EV3 is going to be reading in degrees. All right, so the next variable, or the last variable we're going to be using, is just called check. So I'm going to click make a variable, and this one's just going to be called check. Check. So again, we'll get to that one a little bit later, but now I'm just going to grab out my 3 variable blocks, and I'm going to set them. For now, it's going to be 0, but I'm going to change them later. So the second one is going to be rotations, and the third is going to be check. All right. So we've defined our variables. Now we pretty much want to reset everything. And I talked about the gyro, but we also want to reset our degrees for our motors that they're measuring. So right now you can see that it says 10,000 or 1,085 degrees, and then the other one is 1,124 degrees. So we want to reset this, because when we're counting our degrees or our rotations, when we convert it, we don't want this prior information to be messing up with it. So when we reset the degrees, it's going to be 0. So it's going to show 0 degrees for motor B and 0 degrees for motor C. And by the way, B and C are the motors that I'm using to drive. So I'm going to go all the way up and take out the 2 reset blocks. So I'll reset this one and that one. So I'm just going to change the first one to B, and then the second one to C. All right. So now we've reset our motor. So next, since we're dealing with motor, let's just go ahead and define which movement motors we're going to be using, because you have to define that in order for your movement motors to be B and C. So in the movement tab, movement always has to do with 2 motors, which are going to be your driving motors. So you have to define which ones you're going to be using, because you could be using other ones rather than B and C. And you have to tell the robot that you're using those. So I'm going to take out a set movement motor block, and then I'll just keep it as default because that's what we're using. We're using B and C. All right. So next thing we want to do is reset and calibrate our gyro. So if we go down all the way to sensors in the gyro tab, or where we see gyro, we can see that we have a bunch of different blocks for the gyro. There's a reset angle, which is what we want, so I'll take that one out. But there is not a calibrate gyro, and I believe there's a calibrate gyro sensor in maybe a make code. I don't remember, but there's none in here. But there's a way that I found that you can recalibrate a gyro without a specific block for recalibration. So this one, you don't have to understand this part, just know that it recalibrates. So in order to recalibrate, what we want to do is we want to measure something called angular velocity, and then we want to measure angle. So the gyro sensor actually measures 2 things, not just angle. So it also measures how fast something turns, which is called the angular velocity. And you don't have to know what that is because we're really not using it. We're just using it to recalibrate. So I found that if you measure angular velocity and then measure gyro, then your since it's switching what it's measuring, it recalibrates itself. So that's what we're going to do next. So in order to do that, we're just going to write it on the screen so we know that it's measuring that. So I'm just going to go all the way to the display tab. And remember, the display tab has to do with the EV3. And I'm going to take out a write block. So this is going to write something on the screen. And what we want to write is a measurement. So we want to write first the angle. So I'm going to go all the way down to the gyro section, and I'll just take out angle. It doesn't really matter what line since we're not going to be using this. But then I'm going to duplicate this block like that and put it under. And then this second one is not going to be angle, but it's going to be angular velocity. So now it's measuring two different things, and when it does that, it recalibrates itself. All right. So is everybody like up with this? Or did I lose some of you guys? All right, I'll take that as a yes. Let me know if you guys have any difficulty understanding something.
Yeah,
All right.
Brandon has stepped away from the keyboard for a bit. But how about Mitch? Mitch and Karthik, are you all doing the programming along with Aid?
Yeah.
Awesome. And how about Mitch? Did you get it too? Mitch, are you doing programming along or are you just watching?
I can't hear you that well.
Okay, so that's Grace. Grace, you can't just hear me, or Aid's volume is low too. Is it just me? Okay, we have students who are following you, Aid. Go ahead.
Okay. All right. So where were we? So we've now made our variables. We've reset our degrees for our motors. So they measure at 0, or they're starting from 0. We've defined which movement motors we want to use, B and C. Then we've reset, and then these two blocks are to recalibrate our gyro. So now it should measure correctly, but it always can mess up. So just note that. What's that?
Shouldn't we write the angular velocity at like line 3 or 2?
No, it doesn't really matter.
Oh.
Yeah, it'll just not show it. I mean, we just want it to actually to measure those values. It doesn't matter if it's on top of this text or not. We just want it to measure it. All right. So next thing we want to do is we want to wait a second. So after this calibration, we just want to wait 1 second, and then we'll actually start a program. So before we do that, we also want to clear our screen just in case we want to write anything else. So I'll just go up to the display and then just take out the clear screen, and that just wipes everything off the screen. And then now we want to wait 1 second. So I'll go to the control tab, and then we'll take out the wait block. So we're just going to wait 1 second after this recalibration to make sure it's done it properly. And then we'll start our main program. So now we're going to use our first variable. So I didn't want to put all this code, all of these blocks in just one huge stack, because that would be really, really long and it'd be hard to read. So instead, I was going to divide it into 2 different stacks and then use a variable to let it know that we've switched on to the other stacks. Or the other stack. So I'm gonna bring out another when program starts header.
Can't
So
we
I'm gonna bring out this.
Can't we just use my blocks?
We're gonna be using one for the entire thing. So I didn't want to use it midway and then put it in another one. I just wanted to use at the end. We're gonna have just 2 my blocks, and that's gonna be for the first stack and then the second stack we're about to make.
Okay.
All right. So I'm going to take out another when program starts, and this is going to be pretty much everything under here is going to be our main gyro moving straight program. So now we want to let it know that we've switched to this stack, and we also want to make a program here so that whatever is in this block doesn't start until this stack is finished. All right. So what we're going to do for that is we're going to use our check variable, and we're actually going to go all the way down to the control tab, and we're going to take out a wait block. So it's the second one down here. It says wait until. So that's going to go here. And what are we going to be waiting until? We're going to be waiting until our check variable equals 1. So we're going to go all the way down. And now we're going to be using one of the operators. So we're going to be using the equal sign 1. So the one that has, yes?
You actually know you can type words in there.
What's that?
You can type words in the variables and set them to words instead to make it easier.
I'm not using a word though. We're using numbers.
Yeah, but if, like, I mean, because it might get confusing, like what 0 is and what 1 is.
I'm not sure I follow. What do you mean?
Like, you can set the variable to, like, a word like yes or no, or, you know.
Okay. So you're saying like we should use yes or no instead of like 1 and 0?
Yeah, that might be easier.
I mean, you can, but I like to use 1 and 0 because you're not gonna, like, if you program with like a touch sensor, it doesn't show you 1 or yes or no. It shows you 1 and 0. So it's a good habit to get in, like, to know 0 would mean not on or off, and then 1 would mean on.
Oh, okay.
But yeah, you can definitely use that. So yeah. So now we're gonna set our check variable, or we're gonna wait until, so this program in this stack is not gonna start until our check variable equals 1. So up here we've set it to 0, and we're actually not gonna change that. So then when this program is done, then we wanna set it to 1. And that'll let it know that we wanna start the second header, the second stack. So we're just gonna go all the way down. And we're going to take a set check variable, so the same block as before, all the way on the bottom. So we're going to want to set this variable to 1 now. And then when this is 1, then this program will start. So now we have to put something in this block. And so remember, every time we see the hexagon or this pointy kind of shape, we always want to use some kind of logic or some kind of statement that we want it to read and see if it's true or false. So we're going to say wait until check equals 1. So we're going to be using one of the operators, the equal sign 1. And we're going to set the second number to 1. And the first number is going to be our check variable. So I'll go to the variable and then check. So this is saying that it's going to wait until our check variable is equal to 1. And then once it's equal to 1, then this program is going to start. But while it's 0, which is from here, from this first block to the wait 1 second block, is going to be equal to 0, which means that our program, our second stack, will not start. All right. So you guys kind of understand that?
Yep.
Awesome. All right. So let's go ahead and finish the rest of this program. So now we just have I don't think it's that many blocks left, but now we're going to start our actual program. So right now, if we were to play this, nothing is moving yet. So now we have to make our gyro move, or sorry, not our gyro, our robot move using the gyro. So we're going to be using a repeat until block. So let's go all the way up to control, and we're going to take out a repeat until. So everything in here in the repeat until is going to be our gyro directing our robot to keep straight. So if it moves to the left, it's going to correct it and say move straight. So the logic, remember every time we see the pointed shape, we always want to think of a logic of the statement that the robot's going to have to read to see if it's true or false. So we want to repeat this for the same amount of rotations that we're going to be measuring. So we want to, this is going to be the tricky part. We're going to have a really long statement in here. So, oh, and I also think I forgot one variable. Sorry, we have to make one more variable. I'm remembering now. So let's go all the way down, and we're going to make another variable. So this is going to be called average rotation, right? So average rotation. Average rotation. And so this one is going to be the average rotation of our two motors. Since we're using two motors, right? We want to we can use one to see how many rotations we've gone, but I don't know. It would kind of be better to use two and take the average of it to get a more consistent reading every time you run the robot instead of just using that one wheel. But in theory, they should be around the same number when we run it. But just in case, it's a little off, we get that middle value instead of going to one of the extremes. So we're going to be repeating until, and then now we're going to have to use a really big statement. So first we're going to be using an or. So if you guys go to operators, there's an and or not. We're going to be using the or. So what this does is it repeats until something is, well, there's an or in here, so you can put two different statements in the or, and then it'll take either one of them, and when either one of them is true, or sorry, when either one of them is when either one of them is true, then it's going to stop this loop, this repeat until. And just a side note, the difference between the or and the and is if I put the and here, that means both of these statements that we would put in here have to be true. Whereas this, any of them, either this one or this one can be true. So we're going to be using or. And the first statement we're going to want in our or is we're going to be using our average rotation now. So we're going to want it to say to stop this program when our average rotation is greater than what we put in. So we're going to take out a greater than sign in the operators. It's this one here, and we're going to put it in our first section.
Coach Aid,
Yeah.
do we need to set our average rotations to something at the beginning?
No, we actually don't have to do it yet.
Okay.
Yeah. Because I mean, in this variable, it's going to constantly change. So it would kind of be, we don't really need to set it to anything up here. All these first three variables have to be set at the beginning. Oh, give me a second. The first three variables have to be set at the beginning because we're going to be using them throughout. They're going to be something called constants. So they're not going to be changing. This variable, the average rotation variable, is going to be changing because as the robot moves, the amount of rotations it's gone is going to be changing. So that's what that's going to be measuring. All right. So in our first block, we want to add our average rotation. So that's going to be this first one here in my variables section. So it's going to repeat until our average rotation is greater than, and then we want to use our rotations now. So now we're going to go to rotations. And this is also the tricky part to kind of understand. So you see two rotations. So what it's saying is that we want to, everything in here, we haven't made this code yet, but everything in here is going to be our gyro moving straight. And we want to continue that moving straight. We want it to continue correcting our robot for however many rotations we put in here. So we've set it to 0, but if we wanted a robot to go 5 rotations, the way we would do that is we would monitor how many rotations it's gone and then how many rotations we want it to go to. So this number is 5, and then this average rotation, we haven't done anything with it yet, but that's going to be how far it's moved so far. So this average rotation is 1. That's not greater than 5, right? So that means it hasn't gone at least 5 rotations. If it's 2, then it's still not 5. So once it's at least 5, then it's going to stop because it's going to be greater than what we want it to go to, right? And let me know if that didn't make sense. But yeah, so okay, I think Grace said she wanted to rejoin.
Wait, there's 2 Graces.
She might have joined with another device.
Oh, never mind. She left with the other one.
All right. So average rotation. So the next block we want to do is we put an or. So we also want to see if it's equal to the amount of rotations, which is actually better for us. We don't want it to go too much over how many rotations that we're wanting it to go to. So we're going to take out another operator block, the equal one, and then we're going to put the exact same block. So it's going to be first average rotation and then rotations. All right, so now our robot, if we were to run it, it's going to run whatever's in here for, I set this to 5, for 5 rotations. It should be like almost exact to 5, but it could go a little over, but it shouldn't be too much of a problem. So right now it's going to be taking however long the robot has moved, which is average rotation, and it's going to compare it to 5, which is what we've set the rotations variable to. So if it's greater than how many rotations we set it to, then it's going to stop the robot. If it's equal to 5, then it's also going to stop the robot. All right, so now we want to create our main program. And then in this one, we want to start our robot moving. So this is going to be where we use the gyro. So we're going to go all the way up to movement, and we're going to start our robot moving at 50, 50. So we're actually going to be changing the speed in which it's moving in order to correct itself. All right, so now this is the part where we have to think a little bit. So I'll actually show this robot. So what do you think we need to do in order to use the gyro? Let's say that the robot is moving, right? We have the robot, it's moving, and then I push it on the right side. So now it's moving towards the right. What would it need to do in order to correct itself?
It would need to check the gyro's angle and then turn however many rotations the gyro turned until the gyro's degree is pretty much 0.
Exactly. So we want since we've reset our angle on the left side, it's going to be reading 0 when it first starts, right? And so anything besides 0 means that the robot has turned somehow left or right, right? So anything besides 0 is going to say that it's turned, and then we have to make a program to say that if we don't have anything if our reading is nothing, something else besides 0, then it needs to turn back until it equals to 0. So yeah, this is going to be the hard part, and this is the part where you have to think and kind of understand what we're going to be doing. So now we want to take an addition block, and I'll explain this. It's better to explain after we've made the program. So I'm going to take out an addition block, and that's going to go in here first. So every time this runs, we're going to have our motor. The first number is going to be 50, which was the same as the speed. And then this plus, everything in this plus is going to be the robot compensating for if it's turned or not. So how do we do that? So we want to first put another plus, or sorry, another multiplier. I'm stuttering a lot today. All right, so we're gonna go and take out a multiplication block, and that's gonna go in the second one. So now the robot's going to be adding something times something else. And what we want to multiply is our multiplier, which is the name of the variable. So we're going to take out a multiplier, and that's going to go in the second one. And then the first thing is going to be our gyro, so the angle of our gyro. It moved out. So this is what we want. So we want our 50 to be added to the angle of our gyro times a multiplier. Is that a plus? I can't see well. Yeah, that is a plus. Sorry, you want the multiplier, the one with the little asterisk.
Well, what would we do with the multiplier? We haven't set it to anything yet.
Yeah, we haven't set it into anything, and that's what we're about to do. So the multiplier is tricky. So with this program, right, it's taking the angle that the gyro is measuring and then multiplying it to a number we haven't defined yet, the multiplier, and then adding it to 50. All right, so I actually have the program on here already. So I'll just show you guys what it kind of does. So I don't know how well you can see that, but if I play it and I move right, just watch what happens to the wheels. So I'm gonna. Do you see that?
One gets slower.
Exactly. So when it's straight, they both move at the same speed. But then if I turn it right, what happens? The right motor moves fast, and then the left motor gets slower so that it can turn left. And then if I turn it left, then the left motor gets fast, and then the right motor moves slower, right? So that's what we want, because in order to turn back, we need to make one motor move faster than the other. So if we're adding this first one here, what do you think we're going to be doing with the second one?
Subtracting.
Yeah, exactly. So we're going to be subtracting. And then, funny enough, we're going to be able to make this so that it can readjust itself if it's turning left or right. So it's adding the angle to, sorry, it's adding 50 to the angle times a certain number. So our multiplier, and then this one, this is what you have to experiment with. It's going to be a number that it's going to multiply to the angle. So if the angle has moved 5 degrees to the left instead of 0, right? It's going to multiply 5 times the number and then add it to 50. So this multiplier basically is how fast you want your robot to react every time it moves. So it can be like a sharp turn. So if it's going and then it moves, it quickly readjusts itself, or it can be like a really, really gradual turn. So that depends on how high your number is. So a really low number would get you a really slow reaction time, and then a really high number would get you a really fast reaction time. So I played around with it, and I think I got 1.5. So that's what I'm going to set my multiplier to. So around 1.5, it should work well. And I think it might have been a little higher than that, 1.6. And you can play around with it. If you build the EV3 base robot, you can definitely use this program if you have a gyro sensor. Just attach the gyro sensor pointed forward on your robot, and then you should be able to use this program, and it should be able to move straight. And then if you can, experiment with the different multiplier values and let me know which one you think is the best. So that's the one that I thought was the best. And it could differ from robot to robot since some of them might be heavier than others. So yeah. So now we've set our multiplier. So whatever the angle that it's measuring is, it's going to multiply to that to 1.6, and then it's going to add that to the speed. So right now, if my gyro moves to the right 5 degrees, it's going to multiply 5 times 1.6 and add that to 50. And then it's going to turn back to the right, hopefully. But we have to set the other one to move slower. All right. So we're going to take out this exact same block. So I'm just going to duplicate this one. So just this one. This, we're not going to add anymore. We're going to subtract. So we want to now subtract. So I'm going to take out a subtraction block. And then this first number is going to be 50. And now it's going to subtract 50 minus the angle times the multiplier. So same blocks, just instead of adding, it's going to subtract. All right. And so this should work even if our gyro turns at a negative angle, because a negative angle would mean that it's going to multiply this speed, this negative speed times a positive number, which would get us a negative number. And then it's going to subtract the negative number from a negative number, which means it's going to add. So if you don't understand that, just know that if we have a negative, then that means it's going to do the exact opposite. So positive is going to make motor B, this motor, go faster, and then it's going to make this one go slower. But a negative number means that this one's going to go faster and this one's going to go slower.
Coach Aid, I have a question.
Yeah.
Why do we have a 50?
That's the speed that we wanted to start to go from.
Oh.
So this was, if I take out this block, it shows 50. That's just the speed that's going to go at, that's going to be its average speed, basically, 50%.
Okay.
And you can make it faster or slower, but we're probably going to be want to go at 50 speed because we want to go fast. We only have like 2 minutes, 30 seconds. All right. So the next thing we want to do, so this is basically the bulk of our program. So next thing we want to do is now monitor the average rotation. So we could just get degrees and then divide it by 360 because there are 360 degrees in one rotation. But we're going to be using both wheels, and now we need to make a statement for that. So every time this runs, we want it to set, we want to change our average rotation variable. So if you go down to variables and take out set average rotation, we can now add them and then divide them by 2. So do you guys know what average is?
Yeah, but I don't know how to calculate it.
All right, so the average of something is basically all the numbers combined and then divided by however many numbers there are. So if I said, I don't know, I can't think of an example, but if I had like the number 1, the number 3, and the number 5, and I wanted to see the average of those numbers, what I would do is I would add 1 plus 3 plus 5. And then since I have 3 numbers, I would just divide it by 3.
3
So
is
that would
the
get the
answer.
average, yeah. What was
3,
that?
3%. 3 is the
No,
average.
so average is not a percent. Average is basically like the, I don't want to say the middle, because that's a different thing. It's just like whatever, I can't really describe it. It's like the average. I don't know, like if I said 100 people, I don't know. I'm trying to think of an example. So like on average, how many people have, I don't know, gaming systems in their houses? So that'd be like in like the middle, like about how many. It's not a specific number. It's just it takes all the numbers in account and then averages it.
So
I
3.
can't really describe it.
So 3 would be the.
Let's see. What's 5 plus 3 plus? Yeah. So 5 plus 3 plus 1 is 9, and then you divide by 3. So 3 would be the average of that number. And notice how 3 is in the middle of 1 and 5, right? So that's kind of what the average is. It's kind of like the center, the middle value. So now we're going to average out the average rotation and set that every time this runs. So to do that, we want to take out a plus block and then a division block. So we're going to first, we'll leave that there, but we want to divide. And then this plus block is going to go in the first one. And then we're going to add our 2 degrees and then divide them. All right. So sorry, not speed. This should be degrees counted for A. Uh-oh, the block came out. So degrees counted for A is in the first one. Sometimes I swear these blocks. Oh, there we go. Okay, so degrees counted for A, and then I'll duplicate that. But we're using B and C, so we have to change these. So this one should be B, and then C, and then we're dividing by 2. So that's going to be the average degrees, but what are we using? Are we using degrees or are we using something else?
Rotations.
Yeah. So I know I'm pushing like your math knowledge with this, but how would we convert degrees to rotations? Does anybody have any ideas?
I need to think about that. Well, 1 rotation is equal to 360 degrees.
Yep.
So divided by 360, something divided by 360?
Perfect. Yeah. So we're going to divide however many degrees by 360, and that should be our average rotation. And then the statement now has something to work with. So if we go down to operators and then take out a division block, another division block, we're going to take what we just got and put it inside this one block. So we're using a lot of math blocks today.
The only thing
It's
I
hard
don't.
to move after.
No, you can use the
There we go.
Yeah.
All right, so this last number is going to be 360. And then that should give us our rotations. And so again, it's okay if you guys don't exactly know every single block or every single part of this program word for word. As long as you kind of have an idea of what it's doing, and you can point out to judges like these 2 blocks are resetting the gyro, and then these 2 blocks are calibrating the gyro, you should be good. But it's also good to understand what it's doing. So like, you know, this section is going to be running the gyro, and this everything here is going to be setting our variables and calibrating and resetting everything. But you guys should be good. So the next thing that we want to do is, I think I used the right block, but you don't have to. Yeah, so I had a right block, but you don't have to. I just wanted to see how many degrees it's counted to see how accurate it was. But we could do that. So I just use the right, this block, and actually I'll use the other one, this one, and then I put in rotations, or sorry, degrees counted, and I just used motor B. You could do both, but I just used B. And then you can change the line it is. So I'm not exactly sure, but there's like, I think there's like 120 different spaces on the screen. So if we wanted to get like the middle, that'd be about like 60.
0.
I'm just estimating. And then
feel
I think this one is also 60.
Isn't 0, 0 like the middle of everything?
0, 0 is at the top left corner.
Really?
Yep.
Oh.
So like 60, 60, or somewhere close to this would be the middle. I don't know exactly. I don't know how many different pixels, not pixels, or like how many different sections they have for text.
You can change the font, large
Yeah.
white.
Yeah, you can change font. I'll just keep it as the normal one. But that's pretty cool. You still can't change size though. But let's see. So after this is done, what do you think we need to do? And this is the easy part. What do you think we need to do after we have run our, or after this has, so up to now, we've set our state
You're breaking up.
here to stop the motor, rotate it in. So,
You're breaking up.
all right, how about now?
Your picture is frozen, but we see your screen.
Okay, I'll stop my camera and start it again. All right. Am I moving now?
Yes.
Awesome. All right. So just, can someone take a guess? What do you think we need to put after this? There's only one block left.
Reset the gyro.
No, we're done using the gyro. So as of now, the robot has gone 5 rotations, since that's what it's set to. It's gone 5 rotations. So what do we have to do?
Can we get a hint?
It has to do with motors.
Continue moving the motors.
Why would we continue moving them if we've already gone 5? We only want to move, in this scenario, we only want to move 5 rotations. So
stop moving.
What do we need to do next?
Stop moving.
Huh?
Stop moving?
Exactly, yeah. So we need to stop the motors. We never really defined that. So the robot's not going to take a guess and say, maybe we want to stop moving. So we actually have to tell it to stop moving, or else it's just going to keep on going. Because remember, this block, where is it? This block, this just tells it to move. If we were to play this block in our, when programs start, it's just gonna move forever until we tell it otherwise. So you have to actually tell it to stop. So the stop is here, so stop moving, and that's it. So now if you were to try this program, it would move for 5 rotations, and if you were to push it from the side, it would correct itself. And so you can change this number, which is cool because we have a variable. You can change this to 8, and then it would move 8 rotations. And if you change it to 3 rotations. And if you change this multiplier, if you make it a higher number like 2, it would move sharper. But then you also get a problem. It also wiggles really badly. And then if you reduce it, it'll move really slowly when it's correcting itself. So
isn't our program done?
Yeah. So our program is done. The next thing I want to do, that took way longer than I expected. The next thing I want to show you guys is how to make a my block. And then I was going to do the other gyro program. Maybe I'll just go over that one. And then we'll focus on design and prototyping stuff. Because that took an hour. And we only have an hour left.
Tinkercad? Can we do something in Tinkercad? Or like design?
No, because we don't actually have something we're going to do yet, right? We have to decide on what we're going to do, and then go through the design process before we start even thinking of Tinkercad. But yeah, we'll eventually get there, just definitely not today. We have to first come up with our project. All right. So my blocks, yes. So a my block basically allows you to turn like this big chunk of code into one simple block that you can use. So if you go all the way down with the variables, there's a bunch of stuff you can use. So you can make a variable, make a list, and we might talk about that later. But the last one is make a block, a my block. So you can turn a long list of code into just one block, and that allows you to use it really simply. Instead of having to look at this huge block and then change a bunch of things, you can just have it in one simple block and put the rest of your program. Because right now this just moves straight. If we want to move straight and then turn and then use I don't know, whatever the mission is, if you want to pick up something or launch something, that's going to be a lot of code. So instead of having to put this block a bunch of different times, since we're going to be moving at different times, we could just use that one block and put it a bunch of different times. So to make a my block, you first click make a block. And then it'll bring you to this screen. And then the first thing I'm going to do is name it. So we can name this one, we're going to be making two. So I'll name this one calibrate. So it's going to be for that left stack. And then it's going to have all of this on the left. So now you can add a couple different things. So you can add an input statement. There's two different types of inputs that you can add. Just a normal text or number that you want to add, and then that'll change everything in the program, or you can add a label. So think of this as kind of your variable. So this will be basically our variable that we can change the number. And we're going to be changing the number of rotations. That way we can type in how many rotations we want our robot to move, and then it'll just input that into our code. So we want to add an input, and click just add input, and then you can name it. So rotations, that's what I'm going to name it. And then you can add a label, which we want to add, since if we go back, we might not remember what it is. So I'll just type rotations again. And so this first rotations is not going to show with our actual block, and you'll see that later. But then I'll just click save. And we could actually add two inputs, but I'm just going to keep rotations. Maybe we could add multipliers in the future, but I'll just keep it as rotations. So now I'm just going to take out everything in this first stack and put it in the define. And we don't even need this when program starts. We'll just delete that. So we have this rotations, and then if you take it out, you can put it in the rotations variable. So anything we type in this rotations is going to put it in here, and that'll edit our entire program. So when you make a my block, this is the block that comes out. So this is the block that we've now created. Congrats, you've made your first block in EB3. So now if I type in 7, this is going to go for 7 rotations. That's basically what this does, and it can change. So if you type in 5 and so on. So I'll delete that one. Oh, not duplicate. And then the next, we want to make another my block. Since that just calibrates, now we just want to move. So I'll just title this one gyro move. Nothing fancy. Gyro move. And then we also want to, no, sorry, we don't want to add an input. There's nothing really to input. But then we just want to save this one as is. So this is just going to do what it's doing, since we've already changed the rotations with the first my block. And then with this one, we're going to do the exact same thing. So we'll take out all of that code and put it in the define, and then we'll just delete that. So does anybody have any questions on making a my block?
No.
Nope. Okay, let me know. So we've made our my block, or rather we've defined our my block. So now we actually have to use it in a program. So if we were to play this, nothing would happen. Since these are now, instead of running, they're just going to be defined to make our blocks.
Sort of like
So we
functions.
have to, what's that?
Aren't my blocks sort of like functions?
Yeah, they're exactly like functions in make code. They're just, yeah, called different names.
I have a question.
Yes.
Once you make a new program, would the my block save?
So are you asking if you can use this my block in a different program?
Yeah.
Unfortunately, no. So you have these two blocks, this big piece of code has to be in your program in order for you to have the my block.
Oh, okay.
Yeah, it doesn't transfer from project to project, which was I was kind of sad about. I think you could do that with the other make code without actually having it in the same section. But the good thing is that if we're gonna be moving one rotation at 7 different points, we don't have to duplicate this big piece of code 7 different times. You can just use this block 7 different times, which is a lot of a difference. So let's go up to when program starts. We'll get out this block, and then we'll just put when program starts, we want to calibrate, and then for however many rotations we're going to go, let's start off with 5, and then we want it to move. And we are done. So this should work. I'll actually show you guys. So let me hop on with my phone, and then I'll show you this program in action. I'm going to turn down the multiplier. What's that?
I made my program in literally 2 blocks.
Say that again.
I made my program in 2 blocks.
Your gyro program?
Yeah.
You made a different one?
No. Oh, okay.
Oh, you're saying we made it in these 2 blocks.
Can I share my screen real quick?
Hold on.
See, I only have 2 blocks. And the whole program works.
This is your gyro program?
Yes.
Well, you have to define your blocks.
Everything else is over here.
Oh, okay. Well, that makes sense. So you only have 2 blocks for your program, but you're defining all your stuff on the right.
Yeah, I put everything else to the side.
Yeah. All right. So let me record on my phone.
Pin has video.
So I'll stop sharing, and then I'll record on my phone and then show you guys this program. Oh, actually, before I do that, I should mention, so I guess we didn't get to the other, I'll show it real quick, but I also made a program for 2 gyros, which is fancy. So this is the program for 2 gyros, and it's not much different. It just takes the average of the 2 gyros, and that's pretty much the difference. But it is, I think it's slightly a little bit better with accuracy. So it moves a little bit more accurate. So if you guys can see on the robot right now, I have 2 gyros mounted on it. And so it's going to be up to you guys whether you want to use 2 or 1 gyro. So I think I told you guys the loophole that I found. You can use as many sensors as you want. You can only use 4 motors, but you can use infinitely as many sensors as you want.
How is that possible? Because you only have 4 ports.
So what I was thinking is that if you have an attachment, right, and the attachment uses a touch sensor to like calibrate its position, right, you can attach that touch sensor to the attachment. And then when you switch the attachment, you have 1 port open, right? So that last port, let's say it's port 4, it'll be open for attachments. So when you put that attachment on your robot, you just plug it in real quick.
Oh.
So yeah, you can have like 10 attachments with 10 different sensors, or there's not 10 different sensors, but you can have them with a bunch of different sensors on them and then put it on. So I was thinking that's pretty cool, but if you guys want to like save space and you don't want to use 2 gyros, like that's up to you guys. I just made 2 of the programs that they're literally the same thing, but it's slightly more accurate. Before we do that, I'll show you guys the gyro turn. So we made it go straight, but you can also use the gyro to go to turn at a certain angle. So this one is also kind of long, but I'll explain it really quickly. So at the top here, we're setting our angle to 90, and this means it's going to make a 90-degree turn, right? And this is, if we made a my block, I haven't yet, but you would make this 90 an input. So then we're resetting the degrees for, and this should be B. And we should also have another one. Oh no, not another of that. We should also have another. Uh-oh.
What is happening?
Hold on. It thinks I want to copy the entire thing.
Well,
Right.
you know you can delete everything on the bottom.
There we go. All right. So we want to reset our two motors, our two steering motors. Then we want to, this is the calibrate. Remember, anytime you see an angle, a right to angle, and then a right, and then angular velocity, just know that calibrate. And we can actually leave comments in here, which is cool. So I can say calibrate like that. Great. There we go. So then it resets the angle, and then it clears the display, and then it sets our two movement motors to B and C. And I have it as C and B here, but I think I changed something. So I'll change it back to B and C, but then I have to change everything else. So this should be 30. Sorry, no, this should be -30, and then this should be 30, and then this should be 30, and then this should be -30. There we go. So now that should work. And then hold it really quickly, pretend like you're not seeing this. This should be 5, -5, and this should be -5 and 5. All right, there we go. So now after it sets those two motors, it's going to see if our angle that we've input here is greater than 0, which means it's a positive number, or if it's less than 0, which means it's a negative number. So if we wanted to turn at a positive angle, that means we want our left motor to go faster than our right motor, right? Because we want to turn right. And then if we wanted to turn at a negative angle, we want our right motor to go faster than our left motor. Or we would want the left motor to go at a positive angle or positive speed, and then the right motor to go at a negative speed. So one would go forward and one would go backwards. So that's what this does. And then it starts it. And so this program says, and up to here is everything that you guys have learned, or I think I've showed you. So Karthik, you made pretty much this program. It wasn't this long, but you made pretty much this program when you made the robot go in a square, right? So then we say we wanted to wait until the angle or the angle that it was going at. Sorry, the angle that the gyro sensor measured was greater than or equal to the angle that we put in here, which is 90.
My program, the program that I made was so much more or less than this.
Yeah, because you didn't have all of these calibrates and resets.
Oh.
Yeah, so I took out all the calibrate and reset, and I don't think you had the if because you're only turning 90 degrees. So yeah, it would just be like this, just the two lines. It would just be move and then wait. It would just be 2 blocks.
Okay.
Yeah, but this one I've adapted it to work every time and to work for different angles. Because with yours, you can only turn at 90 or a positive angle if at anything. But this one, if I type in -90, it should work. So the next thing that it's doing, it's waiting until it's past that angle or equal to that angle. And then this is the next part, which is pretty cool. So after it does that, right? And I'll actually show you guys. It's not picking up the gyros. I don't know why. But there's a chance that after this program, after here, it could go past 90. So it could be like 97 degrees. And so that doesn't seem like a lot, but it could mess up. If you're doing 3 missions, it could mess up your other 2 missions if you're turning after the first one, right? So we want this to be really, really accurate. So after that, I have it wait 1 second. And then this program uses a bunch of some math. And so it says that it's going to turn really slowly until it gets perfectly at 90. So then we have this other wait block, which does serves the same function as this one, and it waits until that angle is equal to 90. So notice that we don't have the greater than, we just have it equal to 90. So first we get past 90, and then we slow it down a little bit and get exactly at 90. That's all you need to know about this program. So just know that we're up here, we are resetting and recalibrating. Then we are turning, we're checking to see if our angle is positive or negative. Then we're waiting until our gyro has turned past that angle or equal to that angle. And then we are making it perfect by going at, notice it's only 5 speed. So it's going really slow, and then it's turning perfectly at that angle. All right. So does everybody kind of understand that?
Yep.
Awesome. Okay, so I'm going to, let's see if I can disconnect this and then reconnect because it's not showing my gyro. And I want to show you guys that last part. Yeah, it's not even measuring my, that's weird. I'm going to exit out and then come back. And then we'll work on other stuff after this. So I'll show you guys, or actually we'll work on the other stuff. And then at the end of class, I'll show you guys this program, these 3 programs working. But real quick, I want to show you guys that last part. There we go. So let me share my screen. And I'll connect. All right. There we go. So now it's showing my gyros. So you can't see it, but I want you to watch the numbers. So what it should do first is it first should reset these 2 gyros. Sorry, just focus on gyro number 1. I'll unplug gyro number 2 so you don't see it. So we're just going to be using gyro number 1, and let me switch it out because that one looks like it's acting up. And we're going to talk about that one too. It's called something. It's called gyro drift.
Oh yeah, there's a block in make code that calculates gyro drift.
Uh-oh. This one is still acting up. Yeah, gyros can be a pain sometimes. Hopefully when we recalibrate it, it should work. There we go. All right, now it's at 0. So when we reset it, let's say I'm just going to turn it just because it's at -10. So when we start the program, it's going to first reset this and say 0, even though nothing is moving. And then it's going to turn our robot past 90. And then I want you to watch the numbers. So it's going to go past 90, and then it's going to wait a second, and then it's going to go really, really slowly. So I'll show you this later, but just watch the numbers for now. So let me play it. All right, so there we go. So it's at 1 degree right now, but when it starts, it'll go to 0. All right, so 0, right? Uh-oh, what's not working? It's not turning for some reason.
I think it's because it has the gyro 2 angle there too, and it's getting confused between that because there is no gyro 2.
Oh, yeah, you're right. I had a gyro 2 block. Yeah, you're right. All right, there we go. So there we go. So do you see it's 97? And then look at that. Although it's not 89, that's really close to 90, but it's not 97. It's not 6 degrees past. So I'll show you guys that again. So it starts, and you can hear it turns 98, and then it readjusts itself to 90 or 89. And then I think we can fix that if we make the speed slower. So let's see if that would work. But I'll show you guys it actually readjusting, which it's really cool to watch. Let's see. All right, so watch the numbers again, and let's see if we can get exactly 90. Awesome. You guys see that? So it got exactly 90 degrees. So let's see if it'll work one more time, and then we'll move on. Ooh, so close. But I would take 89 any day over 98 or 97, because that's a lot closer to 90. But maybe we can fine tune it and make it. I mean, I seriously doubt we'd be able to make it go not exactly 90 every time, but 89 is pretty darn close. All right.
Probably
So,
the closest we can get.
yeah, it'd probably be the closest we can get. I mean, I'd still take 89 any day. And especially if we're getting 89 every single time, then we can readjust it to, okay, we can readjust it to go at 90, or even use the 89 and just know that it's going to be 89 every time. But with the other one, you see it gotten like 97. I got numbers like 95 and 96, so it's not consistent. we're pretty consistent with this one. So 89 and 90. So we're going to be using these two programs, gyro move straight and gyro turn, for pretty much every time we move the robot. So if you don't completely understand it now, when we use it more, you'll kind of understand how it works. All right. So let's move on. So we've done enough programming for today, and I'll post the code in Google Classroom as well if you want to try it on your own robot. So let's move on.
We can break the speed G robots that we build, right?
Say that again.
We can break the fast robots that we built with the gears.
Oh yeah. Yeah. Assume if I tell you to build something, assume that you can break it after we've done using it, unless I tell you otherwise. But yeah. And then if you want to use this program, build a base robot, or even use that same one and then just attach a gyro and play it. Let's see. So we were going to work on project, I think. So yeah, let's go to maybe Google Docs and write down some ideas or brainstorm. All right, so has anybody thought more about the project, about what we have to do? First of all, do you guys remember what the project is?
No.
No.
Well,
All right.
sort of.
So we have to build something to get people more active. And I'm trying to find the exact where it is. Let me see if I can find it. But while I'm finding that, do you guys remember or do you guys have any ideas? So what can we build that we can prototype to get people more active?
So we can build on existing ideas, right?
Yeah. And I want you guys all to kind of pitch in as well, because you have to decide this as a team.
I was actually thinking, I don't know if this is good, but a really annoying watch that will keep on beeping and annoy you until you actually get up and exercise.
I like that idea.
Okay, but
I don't know how we would build a
that
watch.
one's, I mean, you guys know what timers are, right? That's kind of like a timer. Like a timer or an alarm that rings until you do, or until you turn it off, right? Nice idea though, nice idea.
This is really confusing. I'm not sure.
Confusing.
Maybe like some sort of like thing, or like robot that like tracks your exercises.
Well, that's like a Fitbit.
Yeah.
Fitbit, like the watch, something like in a watch form, kind of.
Okay. So also think we have to be able to build whatever you guys mentioned. So if you're thinking of like a watch or something, that might not be something that we could build, at least with like a low budget, right?
Yeah, because last year we built like that kit thing.
Yeah.
Okay, so we need something good it's buildable.
Something
Yeah,
that's good that
like
we can build. Yeah,
preferably.
something that would have a good purpose and would align with the theme.
Yeah.
Let's do some Google research. What are some things that get people active, and then we can build on that.
Like a treadmill.
Yeah, you guys can do that on your like laptops right now. Search up some stuff and then yeah, let me know.
I'm not sure what, but something that like every day. So like when you wake up, it's like it tells you to do a small amount of exercises, and then it increases day by day the amount of exercise you're supposed to do.
Yeah, maybe
Okay.
this is challenging.
Coach K, if you're there, do you know where the innovation project stuff is online? I think you're on mute. I can't hear you.
Innovation Award, is that what you are?
What's that?
There is something
Or where
called,
the innovation project stuff is, like the guidelines and stuff for the project.
I can look it up.
An electronic basketball hoop.
That like counts how many
Well, yeah,
shots you've made.
yeah, it would count, but then maybe to get you running a little bit more, it would move around the board, like slide.
That's like impossible.
Interesting.
No, you can do
Well,
treads.
it's not impossible. That'd be hard.
You can use treads or something.
That'd be interesting. There's actually, if you guys know the YouTuber Mark Rober,
Oh
he
yeah,
built something.
Yeah, I know him.
Yeah, he's like my
Yeah.
favorite YouTuber. He builds a lot of cool stuff.
multi
I think I
dartboard.
can find it. Yeah, the dartboard. That's what I was thinking of.
So
Mark Rober, this dartboard.
you know the squirrel one?
Yeah,
Yeah, I saw the
Oh yeah,
squirrel
the
one.
squirrel one.
I didn't know you guys watch Mark Rober. He's
I
really
love
cool.
him.
He
Of
makes
course we
awesome
love-
videos.
He was tested for corona and he went positive and then he went negative again.
Oh, that's scary.
I suck at darts, but I'm
Yeah,
good.
he made his be able to get the bullseye with him, and he also programmed it to do the exact opposite with other people. I don't know if it shows it here, but he went on, I think it was Jimmy Kimmel or one of the late night shows, and he did the same thing.
Yeah, I just saw it. Or like,
Yeah, it's
just
pretty
read
cool.
it.
So yeah, we could, his took, he's a former NASA engineer, and his took like months to do. So maybe not something we can do, but it's pretty cool.
That dartboard took 3 years to make.
What?
I
Yeah,
don't know if it took 3 years. I think it was like 6 months.
They mentioned it in the video.
Maybe he might have been like, he thought of it or it's an ongoing project for 3 years, but I don't know. I'd have to look back on it. But yeah,
Oh,
what do you guys
that's
think?
For years.
No, wait, what I was actually
I like that.
what I was asked, it's
I like the idea.
okay. But it's just really hard to explain. Maybe I can share my screen with the whiteboard and try and draw it out, even though I have really bad drawing skills.
Okay, so what's your idea?
So, like, you know the basketball court I mentioned?
Yeah.
Could we build the model with EV3?
Yeah, I mean, yeah, I don't think there's any restrictions on what you can use to build, but yeah.
Okay, so then this might be a whole lot easier. But let me share the whiteboard. Okay. So, yeah. So what I was thinking is that there's like, you know, let's say this is the basketball court.
Mhm.
And like, there's a hoop right here. Don't judge the bad drawings. Like, let's say that's the hoop. And then there's like a line. There's like a line going around here, and the hoop basically slides on these lines.
So you're saying the entire thing is gonna move in like a square?
Yeah.
Okay. I don't know how we could build that.
Yeah.
Good idea, but I don't know how we'd be able to move an entire basketball hoop. Those things are really, really heavy.
Well, maybe it could be like one of those like little toddler like plastic ones, but in bigger form.
Yeah, I mean, even then, we'd still have to. We want to kind of try to keep this kind of simple. Like, we would have to have something move. I don't know.
I was thinking
I
we
mean,
could build the basketball hoop with Lego pieces, like the tiny one.
that would take a very long time to build
No.
a huge.
No,
Yeah.
not that big, like as big as your hand or something. Not the full hand, like your
So it's
palm.
not gonna be like
Like
a life-size basketball hoop. It's gonna just be one like you could use with like a ping pong ball.
Exactly.
Yeah. Well,
Interesting.
that
I
would
like that idea.
like help you
So like a
exercise.
desktop, a little
Like table.
basketball hoop thing.
Exercise your fingers, boys, people. Even
Like-
like
Interesting. The only one concern I have for that is how much exercise would somebody be getting if they're just sitting
Yeah.
down throwing the ball.
Yeah.
or maybe it's just a miniature version of the big thing.
Uh, okay. I think they did say prototype, but nice idea. We'll put that on the list. All right.
Okay.
Any more ideas? And Coach K, were you
No.
able to find that where the innovation project stuff is?
Yeah, I posted it in the chat.
Okay.
So I
Thank you.
got this Lego. Have you heard about the Christmas Advent calendar? There's like 24 slots. If you open one, there's like a something treasure inside. Have you heard about Advent calendars?
Oh yeah, it's all my.
Wait, there's 24 slots.
There's 24 slots, 24 days leading up to Christmas. So there's like each slot when you open, there is a small Lego model you can build. So I got that. So every day, if I do 50 push-up, I can open one and build a small Lego kit. And finally, you can put them all together into a big kit.
Oh wow, that's cool.
Yes.
Yeah, I'd like that because of the sloths.
Yes. On the last day, you get the Santa minifigure, so you can open that.
Oh,
We could use an idea like that.
like an advent calendar, yeah.
Something.
But
like-
people could easily cheat on that.
as if you don't
No,
have
give it a system. Give it like a security system, and then someone has to monitor it and enter the passkey, which the other person only knows that's gonna be monitoring you.
Mhm. Yeah, like a maybe like text a buddy or something. You finish your workout, only then someone texts you a passcode to open up.
Yes, but if you program it, you should easily know the password.
Yeah.
Wait, sorry, Coach K, this link, yeah, I saw this one, but I didn't see like where it talked specifically about the innovation project. Oh wait, is it
I
a video?
still have no idea what we should do. That would be like
Is it a
that we could
video?
build.
Calendar kind of thing would be sort of cool.
Yeah, that would be cool. But I don't know about the whole like monster thing.
Don't know about
Yeah, I don't see where it was like talks about the innovation project.
it. Okay, let me look.
A watch that transforms into a tiny robot that moves your finger to exercise your finger.
Yeah, not gonna happen.
Okay.
The exercise our fingers enough.
All right, so yeah, what do you guys think? So it could be stuff like that has to do with outdoors. So what would think of you? What would motivate you, or what would be fun to you to get you more active? Could
Oh,
be
I
like
would never
game
want.
or something that you could do.
I never like to go outside, so
But
basically.
yeah, well, okay, so good. What would motivate you to go outside?
I don't know.
I don't know. Well, like if I were to say I have this cool invention and it requires us to, I don't know, play a game or something like that, what would that be?
I would immediately ask, "What's the game?"
Yeah, that's what I'm asking you guys. What it would be that game that you would want to make, or what would be that invention that you would want to make that would get people to go outside?
I don't know.
A trampoline park.
Trampoline.
Again, you're thinking way too big. We have to be able to like build something like tangible, like
Shoot.
unless you have like a bunch of money that we don't know about, we can't really make a park.
I'm a millionaire in disguise.
Oh yeah, sure. If you're a millionaire, then totally, let's go ahead and build the park. That'd be awesome.
Buy a whole theme. We could buy a whole trampoline park and modify it. No.
But yeah, what would you guys want to make? Like, it could be something, I don't know, maybe like an attachment on your bike or something. I don't know. Just think, like,
An
it could be
electronic
something,
bike.
yeah, adaptable, like with something that you could use
E-bike.
every day.
And
Well,
they already exist.
I was thinking something like a boomerang or a frisbee that required you like a running across your whole yard to go get it.
I don't
That
think
would require you to run a.
Okay,
What do you
Like
What do
a
you mean?
frisbee?
So instead of coming back, you would have to run to it.
Well, kind of. Well, I was thinking like along the lines of like frisbees.
Okay, I actually got an idea from Grace. Okay, so you know how she was talking about the frisbee? Maybe
Yeah.
like a tennis ball that you throw,
Yeah.
and then it starts going all over the place, like vibrating. So it goes there, and then you try to run to it, and then it goes somewhere else.
Yeah, I have
It starts
things.
rolling.
Well, then that would be hard to make though.
You guys made me think of, if you guys have read Harry Potter,
Yeah,
I think the
Snitch.
Golden snitch.
bludger. I don't remember I
And
know
the
the
snitch.
snitch
Yeah,
is
the
the one
snitch.
that moves. Yeah. So something like that. That'd be interesting. How would we make that though?
Maybe we could open up the ball and just put something that vibrates inside of it. So
But yeah,
like,
then it'll just vibrate. It won't actually move. I'm
Yeah,
thinking
I think that would like fly or something.
the way not sorry the way C3 or BB-8 moves, if
On
it
a
moves
wheel?
like that, but that's also really complex.
you know,
Yeah.
Mark Rober actually he made the controllable bowling ball.
Yeah, he made it with James Britton, which is also a really good YouTuber. You guys should check him out.
Okay, but I was thinking, like, you know, I'm pretty sure he had some heavyweight inside of it that gets activated once he moves to roll it.
Yeah, but that one, the wiring and electronics for that one is also really complex as well. That one also moves like the BB-8, which is why he did it with that YouTuber, because that YouTuber has made a BB-8 robot. But yeah, that one is kind of complex.
can I show these two videos for the yoga stretch and the kettlebell?
Sure.
Okay, so this is two prime models for stretching and exercising. So let's see this, and you can think something along the line. Okay?
Oh wow, that looks cool.
Oh yeah.
Clicked one new.
Then we'll show your students how to create programs that can graph real sensor data. They'll learn how to correlate graph curves with real life movement, like stretching, and practice doing just that. To complete this lesson, your students will build a yoga ring. They'll use the yoga ring to track their movements on a graph and become yoga pros as they follow the graph data to mimic the tracked movements. To prepare for this lesson, take a look at the Stretch with Data lesson in the LEGO Education Spike app, or watch the following videos. It's time to stretch. They'll start with the resistance bands. Today's a good day to try some yoga. Cool, a yoga ring. He's never done yoga before and isn't quite sure what to do. He wonders if this ring can help him. Time to make your own yoga ring. You can build this one or create your own design. So how does it work? Well, there's a motion sensor inside the hub. When the hub is rotated, it tracks and records the angles. You can find something similar in smartwatches and phones. The motion sensor tracks 3 values: the pitch, the roll, and the yaw. Each of these values is an angle, and that's what we're going to track. Okay, now that you've built your smart yoga ring, it's time to try it out. Let's start with mountain pose. Stand with your feet hip width apart and hold your yoga ring in front of your stomach with both hands. Slowly lift your hands over your head and bring them back down. Great work. Now you'll need to download the program to log your movements. Press the left button on the hub to start logging your data. Your movements will be streamed to your device, so you'll see them logged in real time. Watch what happens to the graph. How do your movements match what you see on the graph? Let's try a second pose, Warrior 2. Start in mountain pose, then step your feet about 1 meter apart. Pivot on your toe and bend your front knee. Bring your arms down to shoulder height, holding your yoga ring in one hand. Log your new movements using the same program structure. Don't forget to change the value from pitch to yaw. Press the left button on the hub to start logging, then practice your Warrior 2 pose. Download the updated program to log your new movements. What's happening to your graph? How do your movements align with what you see on the graph? Now that you've got the basics down, it's time for the challenge. Here's a new graph that shows a yoga session. Can you use your new yoga moves to match what you see on the graph? Look at the value you need to log and adjust your program. You will need to log 2 values at the same time. When you log the values, think about how fast you perform a move. If you can't get it right in the first place, repeat it as many times as necessary. Ready? 3, 2, 1, stretch. When you're done with your session, look at the results. How precise were your movements? Why do you think that was? Another way to do this lesson is to perform the experiment only using the hub. In this case, you'd hold your hub just like a yoga ring. Let's explore math using your yoga ring. Try this. Identify a place on your graph where the values are represented by a straight slope, not a curve. Use the Spike app to find the top and bottom coordinates. Find the math expression represented by y equals mx plus b, where y equals the angle at a specific time, m equals the slope, x equals time, and b equals the angle where the graph starts. This equation will give you the degrees per second you're moving the yoga ring. Now let's explore language arts using your yoga ring. Contact a yoga instructor or fitness trainer in your community and show them your yoga ring. Ask whether it could be useful in their daily practice. Write a report on your findings. Now you're ready to stretch.
That's cool.
I don't really understand how that would be helpful.
It just tracks your movements. Fitbit.
Yeah.
Yeah, true.
So if we have an old phone or something, the tilt sensor inside the phone, if we can incorporate it to detect the
I have a really old phone.
you do.
Oh, me too.
I have like 5 at my grandma's house because they're her old phones. They're from like, well, it seems like 5 million years ago, but
I have a phone that's like Samsung 5, something like that.
oh yeah, I think my grandma has a few like Samsung phones that like are broken down that still have the sensors in them. And I have an Apple one.
Why do we need to use this and instead of using the $100 Apple Watch that you paid for?
What? What'd you say?
No, why do we need to use like our homemade yoga ring when we can just use the $100 Apple Watch that we bought?
Yeah.
Because you have to make something. You can't just buy something. You guys understand like the purpose of the innovation it's a project. It's not a go out and buy something that would
Oh
be useful.
man.
You
Go
have
out
to
on a
make
shopping
something. You have
spree
to use your minds and apply it to building something physical that can be helpful to people.
What
to get-
about an EV3 dancer that you can mimic? I think it would be really fun.
Oh, that'd be
Okay.
Isn't that like
Interesting?
isn't that like already a like a Spike Prime thing though?
But then how many movements can you make? Like how many like
Yeah.
kind of be a little bit limited, right?
Yeah.
I have an
Good idea though. I should probably be writing all this down, but so far we have like the basketball hoop idea or something that moves, like the Mark Rober thing. Okay.
I have an idea.
Yep. What is it?
I have like a model kind of it that would help like explain it, so I'm gonna go get that real quick.
Okay.
Seesaw?
But I'm thinking of something maybe, I don't know what it is, but something that we could like I said earlier, attach to something else. So if it's like an attachment for like a bike that would, I don't know what it would do, but something that you could attach to something you already have, that would be cool. I don't know.
You know the scooters? Maybe like an attachment that makes the scooters go faster.
Yeah, that would also be kind of hard. I mean, how would you do that? And then also, I don't know. Yeah, this is always the hardest part, coming up with the idea. Everything else is a lot easier. takes time, but yeah.
Tougher than programming. Just thinking.
Yeah, because you have to think of like something creative and then something that someone else wouldn't or the other team wouldn't think of, and then if we
And
can
something
either
you can
make it, and
build.
yeah, there's a lot of things to consider.
Okay.
We don't have to pick something today, but
Great.
we should get on that track of like starting to think. But yeah, Grace, yeah.
So maybe we could build something that like makes moves, like how you can like control like one of these things.
Mhm.
Like if we could build like a robot that once you click its button, it'll like have like a different like maybe like a yoga move, and then you would have to like copy it.
But how do we match the accuracy? Like, if we do something,
What?
how do we match up the accuracy of what I do with what you need? Is there any way that we can do it?
I don't know, but like something probably along the lines.
I know. Have have a bunch of ultrasonic sensors in the shape of your body, and if they all detect something at the same time, which means your pose would be correct.
Yeah, yeah. I think you that one too is also kind of complex. Great idea though, but yeah, I don't know how we'd be able to do that with our limitations, I guess.
That's a
But
great idea.
that's a good idea. Yeah.
In VR headset, there's a game like exactly what you said. There are different poses, and once we match that up, we get points. In virtual reality headset, we can play something like that.
Wait, who knows Beatbox?
What?
Beatbox. I think it's a VR game.
Yeah.
Oh, I have VR.
Break all these boxes, and it's really tough, and you have to exercise your arms.
Oh, Beat Saber?
Oh yeah, Beat Saber. It's not called Beatbox.
Okay.
Yeah, that game's pretty fun.
Yeah.
I don't know. Wait, Minecraft went live today. I forgot about that, but okay.
How did that just come to mind?
Yeah, I know. It was so random.
Yeah.
All right. I don't know.
You know what? Like one best project which wins Global Innovation Award will get $20,000 award.
Wait, what?
Yes. I mean,
We didn't get that award. No one got that award last year, did they?
last year they went for the first rounds of it. Remember, free Wi-Fi, they got nominated for the first round. Maybe like they were in semi-finalist or something like that.
Wait, so if you get the best innovation project, you get $20,000.
Yeah.
Okay, we should win that.
Can we split it up if we do?
So you should think to that level, to $20,000 range.
Yeah, I mean, first you got to come up with a great idea before you start thinking of the money.
Yeah, one thing
We need to split it up.
that I remembered, we need a team name.
I was thinking about that as well. Yeah, I think we do need a team name. We don't.
We
I don't think
need a good
have one
team
yet.
name, like how last year, like free Wi-Fi. I like that name.
Robot ragdolls.
What?
Robot ragdolls. Do you guys know what ragdolls are?
Yes.
Yeah.
I
Yeah.
back in Roblox. That game's
Post all your suggestions in Google Classroom, and then we'll put a poll, and whichever gets the most votes, that can be your team name.
Rampaging robots. That might sound a little bit too harsh.
yeah.
All right, but yeah. So think of stuff that we could do for the project. Yeah, great ideas don't come in one day, so this will probably be ongoing. But we definitely need to start. I think we need to start building and working on the project at least by like, I don't know, end of the month. So if we start in November, that gives us a month to do it, or a month or two to do it. So yeah, let's try to come up with a good idea in like the next week or two. How about that? Post if you have an idea, write it down, post it in Google Classroom, tell it to us Wednesday.
I have an
All of
idea.
that.
I have an idea.
Yep.
You know how people like cute robots sometimes? What
Yeah.
if we can build a cute robot with EV3 that wants to that
Like
you
a-
have to that mimics you? I don't know how it'll mimic you, but it's gonna mimic you, and the more movement you do, the more happier it gets.
Or
This would be very,
you build
very
like
hard to make.
a dog that you have to take out for walks and stuff.
A bug?
No, a robot dog.
Oh, you know the puppy? We could modify that.
Mm-hmm.
We are modifying our humanoid robot right here to make it speak
Can I
more.
see?
He's working on it right now. He's making it. Can it speak something?
Whoa!
I remember that.
Remember, right? We are making it more smarter. We are making her talk more.
You guys built that?
Yes, because Aid is talking over and over again, so I'm going to record all his text so she can talk, right?
That's so cool. How do the eyes blink?
Yeah,
Okay.
Aid has been teaching a lot of sessions. So we are going to do knowledge transfer from Aid to this humanoid, do a Zigbee.
Coach Aid, you're gonna get replaced by a robot.
Not replaced. We are creating more and more clones of him. Never ever. We cannot replace him.
Okay, so you're gonna do an operation on Coach Aid's brain, take his information, transfer it to the robot, and then bring Coach Aid back.
Yeah, I don't think so.
So that he can be everywhere. Right now she's going to give just a small introduction. So that's what we're doing.
I have a question.
Yes, great.
Is Coach Rashmi gonna come back?
Rashmi, yes, she's waiting to come back. So, and then she can.
What? Grace, are you not happy with me?
Yeah, but I wanted. I miss Rashmi.
Wow, I took that one personal.
Saturday she can talk with you for an hour, right? Project
Yeah.
ideas you can brainstorm.
Okay.
Ready? Or it will take some time. Oh, okay. It needs some time. We have the first tech challenge happening in the last room. So those kids, they are building another big robot, metal robot.
Wait, are you actually at like Shiva right now?
Yeah, I am.
Oh, I didn't know that.
Oh man, only if we could make a EV3 robot mimic you.
That would be cool.
I mean, you could, maybe there's a way to use your camera on your phone and connect it to an EV3.
Yeah, kind of like how Just Dance is, except you mimic it.
Yeah, that'll be
So that's a lot of programming that I would definitely don't know.
Whatever Grace suggested with that robot, attach a GoPro or something and detect movements and match. So for homework, I mean, like I would suggest each one of you have to post 3 ideas per project. Okay, any 3 ideas. It can be crazy as you want. So
Already mentioned like 4.
yeah, then post it in Google Classroom. So next week for project, you can discuss with Rashmi about which one would be the best project and you can start working on it.
But I actually feel like the basketball hoop I mentioned? And don't we still have 5 minutes of class left?
Yes.
Oh yeah, and I forgot. I wanted to show you guys something.
6 minutes.
Well, yeah,
Well-
but the robot hoop, the hoop I mentioned, can't we like, you know how you said that you can build a prototype? So can it be small? So, like, you could have an EV3 version of a hoop, which is gonna be like as big as your palm or something. And it'll be like,
Yeah, I have to look at the guidelines again. I don't know where it is, but yeah,
Me too.
it's a good idea. Like, we're not dismissing any of the ideas. We're just, I mean, we haven't fully decided what we want to do. So every idea is still on the table.
Maybe something like that has to do with soccer, maybe. Like
Mhm.
have like a robotic net.
oh yeah, that might be a little bit easier.
Yeah, I've seen something like that. A robotic goalie that moves left and right.
Maybe
Oh, yeah.
we
Or the robotic sock. Wait, no, you wouldn't kick metal.
a
Some sort of robotic ball.
robot player that has fully functional AI that you can only beat if you move a lot.
Again, definitely way
I
too
kinda-
complex.
Maybe something like a lot something like Just Dance kind
Wait,
of
Coach,
Yeah,
K, is
dance.
that humanoid?
like something how this like it doesn't move what you can.
Coach
All these
K.
ideas, but
Like
he post all of this, and I said he wanted to show something.
But the humanoid that you were just showing us, can we use it and make it as a soccer player?
yeah,
Pretty sure
But
you have
maybe
to build
something
everything yourself.
like
Oh.
like how you have like a robot that does like a move and then you mimic it. I kind of like that idea.
Yeah. And then you
Mm.
make the robot happier and happier and happier, and when it's full happy, it stays
Yeah.
there for like an hour or two, and then it gets sad
Yeah,
again.
like a virtual pet kind of.
Yeah. And you have to exercise to make it happier.
Yeah, because I
Yeah.
have one of those on my computer where it's like a little cat and you have to feed it and take care of it for it to be happy.
We are
It
ready
talks to you, so.
to see what you have. We are ready.
Wait, what? Oh, okay. Coach A, you want to show us something?
Before that, I think I mentioned this in Google Classroom, but if you guys download this software called LDCAD, let me see. It's not showing on my window.
That sounds like Tinkercad.
It is.
And it does pretty much the exact same thing. So it's a CAD software, computer-aided design software for Lego. So since we only meet Wednesdays face-to-face, you can use this software. Here it is.
Oh, yeah, I have that.
Design in Lego. So you don't have to even have Legos to use this. So you can design in Lego and then like send the files and stuff like that, or you can
Yeah,
actually
I
build
already
the
downloaded
robot
it.
that we've already made, or the half of a robot that we already made in the software for like documentation and stuff, and you can work on it.
Not even half.
My mom downloaded that already, so.
Yeah, and there's a video on, because you have to set up the library so it has all of the Legos and stuff.
Yeah,
I think there's some videos on YouTube that tell you how to do that.
that's the confusing part.
And for project, your parents can be volunteers. They can help with project ideas, how to design the prototype, or to design PowerPoint presentation. Your parents can be volunteers. So if you think your parents are ready for it, let me know. Okay?
Oh yeah, and definitely, yeah, get ideas from your parents and your siblings. Like ask them, I don't know, what would motivate them to go outside and play, or what would be fun to them.
Oh, my
Because
Those siblings.
we want to make this as
ideas.
general as possible, so it'd be good to get input from.
My sister would have a ton of ideas.
I have
Yeah,
no
ask your sister.
siblings, so.
I think Coach K has seen my sister, right? Has Coach K seen my sister? I'm confused.
Yeah, I have seen your sister. Yeah, I love her.
She's hyper and she has too many crazy ideas. So
I have no siblings, so I have to rely on my parents.
you know you can get a virtual sibling. You know, like the cat you were talking about.
Yeah, I love my cat. That gives me 3 cats, so I have a virtual cat and then 2 real cats.
Okay, 2 real cats equal to 1 sibling.
Yeah. I'll just ask my cat, like, meow, yes, say nothing, no.
Oh, okay. Do you want to go? Do you like to play basketball?
Yes, I used to play basketball for 2 years, but I chose robotics over basketball.
Why?
It's 5 o'clock.
Because I wanted to do robotics, and they met at the same exact times on Saturdays, so. We also had someone today, so.
Did that creepy dude just say it's 5 o'clock again?
Yes, he did.
You need to change the voice. It's too creepy.
Where is my virtual pad?
But anyways, he's doing his job, keeping up with the time. So this video, we will post it, and previous Saturday videos also, we'll post it on Google Classroom. And any other suggestions, if you have, let us know.
I have 2, but I have 1, but it might not be as good and helpful. So
Yeah, because
I wanted to show us something. Maybe let's let him do it first.
Yeah, he wanted to show us long time back. Go ahead.
All right, so switch to my phone.
On the phone.
And also, if anyone wants to like take the lead with LDCAD and start modeling the robot, that would be great as well.
Well, could we like wait, never mind. I have an idea, but don't.
All right.
The phone screen. Dot.
Big screen. Where's Fletcher?
He's not here. And in the meanwhile, here. Oh, okay. Hi, Coach Aid. Is that the door?
What the? Where are you? What?
That's a door.
That's a very weird angle.
Yeah.
I can't really tell what that is.
Oh, at least the EV3 isn't rubber banded.
All right. Can you guys hear me?
Yeah.
Okay. Hold on. Let me. Hold on.
Oh, you went in. It's total darkness.
Yeah, it is.
In the meanwhile, here's my idea. Okay.
Okay. Oh, hold on. Sorry. I can still hear myself on my computer.
Oh God, that'd be
Wait,
creepy.
are you logged? Wait, he's logged in on 2 accounts.
Yeah, that'd be creepy. You're talking and some other person mimics you.
All right. Okay. So yeah. So this is you guys' quarter robot. So I've uploaded the programs that we made today. So that was the gyro move straight, and then the gyro turn, and then this one is going for 90 degrees. So let's first do the gyro straight, and hopefully it doesn't act up. So there we go.
Yeah, hitting with this
So this
one.
one is just using that one gyro sensor. It's using this one, I think it was port one.
Shouldn't it be on
Using
the front? Shouldn't it be in the front?
Hmm?
Shouldn't it be in the front?
No, it doesn't make a difference as long as it's pointed in the direction that the robot's moving. So this is going to go forward. As long as it's pointed forward, it should work.
Okay.
And with the second gyro, that other program I told you guys about, I added a second one, but I turned how it's oriented so it's like this, and it also seemed to work well. I don't know why exactly, but it just did. I mean, it's still measuring on like the same plane. It's just turned negative 90 degrees. So yeah, let's do the first program, and I'll try to hit it and see if I can, or let you guys see if it comes back. I probably hit it too much, but you guys saw how it was trying to stabilize itself.
It was so wobbly.
I know.
Yeah, you can turn like the multiplier down to avoid that. So it might be too high right now, but let's see if I can do it again. Yeah, so it might be too wobbly as of now. But you guys see how it works, right?
That's very wobbly.
It's a snake now.
This one does both gyros, I believe.
It's so wobbly.
Yeah.
Yeah, so we might have to turn that value down.
It's a snake car.
All right, so the second one was the 90-degree turn. There we go. So it's this one. So what this one will do, if you guys remember, it'll turn 90 degrees. So it'll turn like this, and then it'll readjust itself to get perfectly at 90. So it's first going to go past 90. So I think it was like 96, 97, something like that. And then you'll see it turn a little bit to readjust itself.
Wow.
You guys see that last movement?
That was cool.
So perfect 90-degree angle. I don't know if it was completely straight, but let's see if we can make it straight.
Yeah.
That just looks so cool. It's like, okay, no, wait, actually, I'm not so straight. Boom. Okay, there we go. No, oh, wait, I'm not straight. All right, there we go.
Yep.
Now I'm straight.
No, I don't know how you can see it, but it looks pretty straight to me.
It is. I mean,
I can't really tell.
But yeah, so it turns and then adjusts itself accordingly. All right, so yeah, that was the two programs I wanted to show you guys.
and now can I say my idea that's really useless, but it will
You
make
need to
you
post
laugh?
it on Google Classroom, okay?
Okay, but it was just something that scares you so much that you run around trying to avoid it.
That's actually a good idea. Something that chases you.
Yeah, it chases you and it's really scary. So it makes a scary noise like
Well,
ah.
maybe not something scary, but something that would like chase you, or you have to run, like, or you would chase it. I actually do really like that
A
idea.
tag robot. A tag robot.
Well, but I think that maybe we should do it like where you have to like chase it.
A trip to the mall goes wrong.
What?
You know what? The other day I was watching this show, and they have a safety kit. You know, they show it in a funny
Like
way.
the kid?
Yeah, what you did last year.
Yeah.
Why are you taking a backpack to the mall? This is my mall safety kit.
Oh, it's Young Sheldon.
Oh
Yeah,
yeah.
I've seen this episode. I love this episode.
Oh yeah, I remember this one.
Yeah, because I remember the girl, she steals something, I think.
Yeah.
So what you did for last year, that project, that's a real thing. I was of your team.
Yeah, I love Young Sheldon. And I've seen The Big Bang Theory too.
Yeah.
Okay then, so keep thinking, and then next week you'll have your project leader. Rashmi will be here. Okay?
Okay, bye bye. I'm gonna go do my math now.
We love you. We want you to focus on the programming. Okay,
Okay.
they all love you. No doubts about it.
Okay, bye.
Goodbye.
I have a question. Do any of you guys play Roblox?
Yes.
Yeah.
I need to friend you guys.
Okay.
I have Roblox up right now.
Okay, well I'm gonna
Same.
go.
All right, guys. Bye.
All right, bye.
Bye.
How does she find you? She asked for your Roblox ID. Do you want to share the ID?
I can
Yeah.
search it up and friend.
Yeah.
Bye bye.